Hi, I'm Mike with House on the Mend, and in this video we're going to be reviewing the Troozy 135E Welder. We're going to be welding various thicknesses of metal. We're going to be doing a penetration test as well as building something fun. So let's get started.
If you break it, he will fix it. If you buy it, he will build it. House on the Mend.
So this welder is a united product between Troozy and Rilon. Now there's two things I want to go over before we get into the review. First of all, my experience. I am not a professional welder. I would consider myself a DIY or hobbyist welder. I've made various projects over the years, including this cage for my van build that these two seats go on top of. This spring-back softball target for my daughter who's a catcher. And I did a whole video on how I made this access door for shooting sports photography and video work. Secondly, I'm neither paid nor sponsored by Troozy. They simply reached out and sent me this welder for my independent review. So let's unbox it and see what you get in the package. Here I've placed everything that comes in the box. We have the unit itself, which is very compact and lightweight, weighing in at just over 12 pounds. Now, coming pre-attached to the unit itself is both the torch and the grounding cable. This grounding cable is copper stranded wire of 16 millimeter, which is 6 gauge, and it comes with kind of a thin, but probably for the light duty capability of this welder, adequate clamp. The nice thing about the clamp is if you want to upgrade it to something more robust, you can simply slide back this little rubber handle guard, and there is a crimped eyelet fitting here that's just held on with a bolt. So you can easily remove this and swap it out if you prefer. Now the torch has a nice grip to it. It's got a big trigger, which will be nice when you have welding gloves on. It has a little hook here for hanging the item temporarily when not in use. And then it comes with two different nozzles, which I found interesting because this pink one that came attached to it is ceramic, and that is typically used for gas welding. And this is a gasless unit. There is no spot where you can attach for gas. Instead, you typically use a nozzle like this that's included. So I'll try it out with each one. The only real difference is going to be the amount of the tip that is exposed. So you can see this one here is going to expose, boy, a good 3/8 of an inch or so of the tip. Now, the torch itself is connected to the unit with kind of a rubber outer hose that is going to have two wires inside you can feel. One of them is going to be for the trigger, and the other one is the feed line for the flux core wire. And this unit actually comes with a 1 pound reel of flux core wire. It is 0.8 millimeter or 0.030 inches. And that's good because that is the most common thickness. You can find that at any home improvement store, easily on Amazon. You can use a 1 pound reel like this one, or a maximum of a 2 pound reel. Very common sizes. Bigger units can come up to a 10 pound reel. That adds a lot of weight, however. So it's nice that we get some flux core wire. Also included is this little wire brush, and it's got like a little slag hammer on it that we'll try out for fun. I actually have an actual hammer and a much more robust brush that I prefer, but we'll give this little guy a try. The power cable is just like something that plugs into the back of a home computer. It is, what, 16 gauge wire, so that's interesting that it doesn't have like a more robust system, but again, this is a light duty unit. Now, getting to the first thing I really don't like, take a look at what is glaringly missing right here, and that is a handle. No handle. Instead, it comes with this nylon shoulder strap, which is kind of a cool idea. I like the thought of being able to strap up all this to a little Velcro strap on the handle and then carry the whole unit with this shoulder strap, but there's no handle. So that is my chief number one complaint so far, is you have to carry it with this big bulky strap. All right, since we have the unit turned this way, let me show you what it looks like on the access door side. So you rotate the door down on its hinge and you have access to the spot where the spool of wire is going to connect. And then this is the wire feed mechanism. As I feel it, everything here is plastic with the exception of the roller wheels down here that actually roll the wire off the spool and through to the torch. Everything else is plastic. Now there is a welding guide, which is very typically put on the door. I like to see that. The only problem is the dial that is pictured does not correspond to the dial on the front of the unit, which we'll talk about in a second. And the range of thickness of material you can weld does not correspond to this unit either. This is a light duty welder that can range up to a thickness of 1/8 of an inch. Anything thicker than that, like if you're trying to fabricate a rock crawler vehicle, you're going to need a more robust welder for. But this guy can handle up to an 1/8 inch, which is what, 3.2 millimeters or 11 gauge steel. That is going to be the overwhelming majority of your kind of hobby welding. All right, let's switch to the back side, and what you'll notice is there is no power switch. We'll talk about how you turn the unit on here in a second, but no actual throw switch for power. There is a spot right here where the supplied plug is received, and then this little fan hole right here. Now, an interesting feature of this welder is that the fan does not go on full time. As you can see in this slide from their Amazon posting, the fan kicks on when the unit raises to 60 degrees Celsius, which is 140 degrees Fahrenheit, and cools the unit only when necessary. So the other welder that I have that I've used for years is a full-time fan on kind of a unit making that droning noise. This one only does it when it needs to kick on and cool down the unit. So on the front of the unit, you have a very simple display. You have one dial that controls everything. So it is turned off here all the way up to here, which is called standby. So there is no power being supplied to the unit. There is no switch. It's just this potentiometer dial. And then you start with 1.5 millimeters of thickness going all the way up to 100% max power, which is a thickness of 3 millimeters. So with the unit plugged in and turned down to the standby or off mode, you can see that the power indicator is just blinking green. Now, I am an arm's length distance away from the unit with my microphone. Listen to how very quiet it is when you turn the machine on. Just the audible click. The OC, or overcurrent, has two functions. One, if there's a problem with the incoming current, so the current coming from the wall. Now this is a 120 volt unit plus or minus 15%, so that's a pretty wide range of power fluctuation that this guy will accept. But if there is a problem, this light will flash, and if it goes on and stays on, then you have an overheating issue. So two-prong indicator with this little red light here. One thing I want to mention about the torch cable and the ground cable is you can see right here the ground is the positive and the torch is listed as the negative. And unlike some welders where you can come inside and switch the polarity, like this picture here, this unit does not allow you to do that in the normal access area of the welder. So I don't think that that's a function, probably due to the smart chip inside. Speaking of the smart chip, the reason you have only one dial is there is a specifically designed computer chip, as you can see in this slide here, that Rilon wanted me to talk about. That chip allows you to just dial in the thickness of the metal you're going to weld, and it automatically ups or lowers the power output to what you're going to need, and automatically adjust the feed speed of the wire. So that is really cool if it works. I'm really interested in seeing if that wire speed is appropriate. Just to demonstrate how much simpler the design is for the Rilon, this is my old trusty Lincoln Electric ProMeg 140, and it has a power switch. It has a separate dial for the wire feed speed and another dial for the amount of power going into the weld based on the thickness. So those three different selections are all taken care of with the one knob on the Rilon. So the supplied manual is pretty brief. It is fairly well written, although there are some comical grammatical errors. It makes it pretty obvious that it's just translated over in Google Translate or something from Chinese, and they didn't have anyone who speaks fluent English kind of go over the manual. So a few things in here I wanted to point out. Number one is that the unit is designed to operate in temperatures of minus 10 degrees Celsius up to 40 degrees Celsius, which is 14 degrees Fahrenheit up to a top temperature of 104 degrees Fahrenheit. Now, here in Las Vegas, where we live, 104 degrees in the garage is common in the summer. So I imagine there's going to be times where I get that overheating light blinking, and I'll have to step away and let the unit cool down, but we'll see as time goes on. Now, on the other side of that operating temperature, please leave a comment below and tell me where you are in this country or where you are in the world, where you are welding at negative 10 degrees Celsius or 14 degrees Fahrenheit, because I want to raise a toast to you for being tough as nails if you're welding in those sorts of brutal temperatures. Now, for storage, the unit is designed to be stored at a temperature of negative 20 degrees Celsius up to 55 degrees Celsius. So that's negative 4 to 131 degrees Fahrenheit. So you might want to watch out for storing this in a vehicle, since in Las Vegas, our vehicles with the windows up can get well over 140 degrees Fahrenheit in the summer in direct sun. So I would just be cautious of the circuitry in here in extremes of temperature. Now, at its heart, this unit is a power inverter. So if you look here on the technical specifications page, you can see that it is taking 120 volts plus or minus 15%, and it is converting that to DC voltage of 16.3 to 18.5 volts. One interesting thing this item didn't come with, though it came with the two nozzles, it doesn't have any of the contact tips included. These are very readily available on Amazon. I'll leave a link to some. It's simply a 0.8 millimeter or 0.030 inch MiG contact tip. It has threads on the unit and it's simply removed by unscrewing it, which we're going to do in just a second when we load the wire. Well, the manual is exceedingly poor at explaining how to put this spool of the wire on. So let's see if we can figure it out together. First thing to do is pull out this cotter pin. And then just before we put the spool on, I want to remove this tape and paper. And then we want to put this spool on so that the wire is going to unravel at the bottom, heading right into this port here. So it's going to spin counterclockwise as it feeds the wire. So I'm just going to pull out the wire from the spool, and you can see it was put in such a way as it's crimped, so that's not going to be able to feed through everything. So let's just cut off that crimp, just like that. Now take down this little knob that loosens this little feeder hole here. We want to feed the wire through this little plasticky hose till it comes out right over here by the rollers. We can slide this up so that it goes right on through into the next port here to head out towards the torch. And then let's slide that as far as we can by hand. That's sliding really easy. I might be able to get it all the way out of the torch. And there it comes out. So to make it really easy, take the cable and stretch it out straight and flat, and this wire will go right through, no problem. Now we'll close this top wheel down on the bottom wheel, put up the little tension knob, and I'm going to leave it where it's set in the factory. If it slips and isn't feeding, you can always tighten this one and this one, but the directions don't really say how. Last thing we want to make sure we do is push this spool back enough that we can put the cotter pin back through to hold it in place. And there we go. That was really easy. So to easily push that wire through, I took off the little contact tip. So now that it's through, I can just simply take the tip, slide it on through the wiring, and then just screw it in place. Just like that. And then we can pick between the two nozzles. I'm going to go ahead and try the one that came installed on it and see how the ceramic one does. Now, as previously stated, I can't get over the fact that there's no handle for this unit. So I went on to Amazon and I bought this pack of kayak handles. And they consist of this plastic handle, nylon straps, and then these two plastic inserts that I am going to slide right inside the unit like this, and then I'm going to put a screw down through the top. And that way I will still have the ability to utilize this upper area here for the shoulder strap. Now the thickness on this rear side was a little bit less than the actual thickness of the handle strap. So I took a grinder and sanded it down a bit, and now it fits in there perfectly without protruding out the back. I can slide the other one in towards the front. Then I'm going to pre-drill for screws. And then a couple of screws to hold the handle in place. Now that's much better. Let's quickly go over some accessories you're going to need for welding. First of all, a welding mask. I like these auto darkening masks. You can dial in the sensitivity and the amount of darkening, but it allows you to see and get set up with your hands for your work, and then it instantly detects when you kick off the spark and darkens for you. These are awesome. This one I loved when I originally bought it because it just screams America. There's one similar in the description below. I also found this one here that's cool that looks like a stormtrooper mask. All right, next you're gonna need some gloves. And I really like these gloves here by Black Stallion, and also non-flammable clothing. So you wanna make sure you're not wearing nylon or something that can catch you on fire. I really like this 100% cotton welding jacket. This was a Father's Day gift and it is perfect. My daughter and I, in fact, each have one. All right, absolutely necessary are these welding pliers. The reason for that are mainly the wire cutters and this little bit of standoff. So between almost every weld, you're gonna need to cut this wire that's coming through, the flux core wire, so that you have the proper standoff, and these are great for that. They can also help you with this little circular spot right here to screw on and off the consumable tips, so very necessary. Now this kit came with this little slag hammer and wire brush. Normally you need to buy those things, so if you look at the bristle difference here, I'm not sure how good of a job this guy's going to do. It's only got a very few bristles. I really like these for cleaning off your weld, so you can get a look at it. And then the slag hammer is good for popping off any little bits of splatter that you might have. If you don't want to go for the full-on jacket like this, I would at least suggest something like these. These go right on your sleeves, and it'll cover and protect your arms and your clothing from getting burned. So finally, time for the exciting part, actually testing out the welder with a weld. And the material of choice, I think, is a very common material for DIYers and hobbyists, and that is 1/16 inch or 1.5 millimeter tubular steel, super common for projects. So we're gonna test that out. All right, now you saw me note earlier about the polarity of this tool. They set it up properly. You might think this would be the ground and that the head would be the positive, but with MIG welding, and especially on an inverter like this, you want the polarity to be opposite of that. So the positive, meaning the actual bulk of the electricity, is going to be running through the steel, and then you have the negative hooked up to your tip running your material through. Now, since this is a 1.5 millimeter, we're going to turn our little dial here to its basic setting right there at 1.5. And I can hear it turn on, but the fan isn't on yet because we haven't been using it. All right, I prepped this tubular steel, as you can see here, with the disc sander, and I got a nice channel like this for the weld to sit in. So without further ado, let's don our safety equipment and let's see how it does. All right, I am standing outside of the loop made by either the clamp or the trigger itself. That way I'm not inside of any kind of electromagnetic radiation or any kind of electrical field. Now with MIG welding, you want to drag the puddle, not push the puddle. All right. Well, for my first weld on this machine, I would have to say it's pretty ugly. As you can see here, we've got splatter and we've got burn through. So I would say that it might be either turned up a little too high, which it's almost its lowest setting, And then also, maybe I'm going too slow. So let's flip it over and try another one. And here's where these pliers come into play. As you can see, when I released the trigger on the nozzle, it left quite a bit of the material sticking out, a little too much to start. So we're going to just clip that off and we're ready to start again. All right, let's try going a little faster and see if that'll keep it from burning out. Yeah, that looks absolutely terrible. Yeah, that is still not good. Even at its lowest setting, it is eating away in the middle there. It started okay and then kind of immediately started melting away the material. So, let's see if I can go just a little bit quicker. It's losing connection and not welding at all if I try to go quicker. It's not liking this 16th inch material at all. So I've tried fast, slow, lowest possible setting, a setting too high that blows out the material. I've tried straight upright, and then a slight about 10-degree angle, which is the norm, so that I can pull the puddle across. And really nothing is very satisfactory on this 16th inch steel. Let's set back up for some 1/8 inch flat steel. All right, I don't want to be accused of having my first run with a new thickness of material and a new welder be the one on camera. So I did take the time to do a test run with this piece here, and things are looking up for 1/8 inch steel. Not so much with my first pass here that wasn't slow enough, but the second pass here, it's still a little bit hot, is a really good run. I went real slow and just tried to keep joining the two materials together, and I think that is a very acceptable weld. There's still quite a bit of splatter all over it, so if you get some of that spray that's available, I don't have any, but you can pre-treat your metal and the little balls of splatter don't tend to stay on it. That's pretty good. Let's do another one on camera. Now the first thing I want to do is tack weld on both corners so that we can move this magnet out of the way but still keep the piece relatively at 90 degrees. Now I do have the ground cable attached directly to the metal. This is a metal tabletop, so theoretically I could put it anywhere on the table, but I don't want to be accused of this surface not being conductive enough. There is some sort of finish on it and affecting the puddle and its ability to create an arc. So I'm choosing to put it right on here. It does splatter on there, and over time you could wear it out, but I want to be as fair as possible in this review. So let's do a couple tack welds right on those edges, and then we'll get set up for a nice long run. I'm going to clean all that flux off of there. All right, I'm just doing a couple runs here to make sure that I'm not going to be the problem with my reach getting messed up as I'm going through. I want to stay nice and steady. All right, here we go. All right, I heard a little bit of spatter noise going on right around here, and I think that was my fault. I think I had pulled away a bit from the material and got back into it over here. That was a pretty slow weld, I think you would all agree. And we're set to our max setting too. And even so, as I clean it up, get all this flux off of it, to my eye, this is pretty good here. It's not stacked dimes by any measure. And then right around here at the center mark, there is a distinct line, you can see in this picture here, where the weld is not the same quality. It starts to kind of break away and never really recovers that well. So I say we cut through it here in a little bit and we'll test to see if we got good penetration. On the line here, I don't see any hint of that other than I can see the heat that came through. So yeah, we'll cut this piece straight through with a saw here in a minute and we will see about penetration. All right, I have these two pieces set up here with a nice V groove in here that we'll fill with the puddle. I already did 2 tack welds, 1 on each side, and cleaned them off with the wire brush. So we're ready to just make this weld and see how it turns out. Now that is by no means a professional weld, but it is a really good solid puddle. I don't see any porosity. The only spot was the ending here that doesn't look too good. That could have been my fault. Let's clean it up, and while we're at it, try this little brush that came with it. Yeah, it works. Just doesn't cover a lot of area. Let's see if we can get any of this slag off with it. Yeah, look at that. Not really getting the big ones on this side, but it got these little ones. All right, I think that's a gimmick. This is gonna be really hot. So, let me just get here. Look. That looks on the surface here to be a really good weld. Let's see if we can get a sense of our penetration. Yeah, I see the heat and I see some weld coming through. So we're gonna cut this one as well and see how that penetration did. That is not bad. It seems to be handling this 1/8 inch. Now 1/8 inch is the maximum and it is handling it. But let's see what it would do on this same test here with 1/4 inch if we also really take our time. All right, same thing. I tacked both corners, brushed it off. Let's see how it does. I'm gonna go really slow since this is such thick material. So it's not the cleanest looking weld, but let's see about penetration. It's certainly not bad. Not sure about penetration, however. But you know what? In a pinch, if you needed to help somebody fix a car repair and get home or something like that, I think it would suffice. Well, just a little bit of time with this wire wheel attachment on my angle grinder did a great job of cleaning up all the splatter along both sides of these welds, and also gave way to a really shiny, nice looking set of welds, especially on this 1/8 inch stock. The weld looks fine on the 1/4 inch stock, but when you flip it over and look, you can see you're not getting penetration, which you can't hold this welder responsible for. It's not rated for something that thick. Now, as I look at these welds, they're not the most professional thing, but I'm not a professional welder. But I do like the fact that there's very little porosity, only one little spot right here, and that was at the end of the weld and could be my fault. Now it's a different story when you flip these over and you see an inside corner weld. In both of these examples, you can see there's just kind of a bead of weld, and it's not taking both sides of the steel in and melding them as one. I think I need to go a lot slower on an inside corner. Well, as you can see here with both the top weld and that inside corner weld, this unit had no problems with penetration on 1/8 inch steel. All right, let's do something fun. Let's do a test of quick welds while we make a fun little piece of fall art. Oh, we're 7 horseshoes in and the fan just kicked on for the first time, so it's doing a pretty good job. And there we go, a pumpkin. All right, I think that's enough testing for me to give you my final thoughts on this review. Let's go to the pros and cons. So the pros, number one, I would say it's weight and portability. Weighing it in only 12 pounds, it is super portable, it's great. My Lincoln MiG Welder, on the other hand, is like 50 to 60 pounds, not including the 10-pound reel that can go in it. So this one can just be carried comfortably, moved around. It's really gonna be a go-to welder for small projects for me. Now, along with portability, we should talk about power consumption so you can get an idea if you can go like off-grid and use it. So at its max power setting, when I was welding 1/8 inch steel, it used 1,594 watts, a little above and below that. So it was right at 120 volts. That works out to 13.28 amps, meaning that your average, say, Toyota pickup truck that has an inverter set in it, that's going to be a max of 400 watts, whereas my van build, that's going to be an upcoming series, has a Renogy inverter that can handle 3,000 watts. So for me, portability in my what's going to be a hybrid work/travel van, I'm going to be able to run this little welder for small projects if I don't have a household 110 outlet to plug into. So I do think it also has portability with its energy usage, as long as you have a pretty beefy inverter on your rig. Next would have to be price. It's usually priced at right around $157, $159, although if you are looking at this video right this weekend during the 2022 Cyber Monday deals, it is down to $134, which is a fantastic deal. If I was watching this video on Cyber Monday, I would pick this unit up without hesitation. It's definitely worth $134. But even at its normal price tag, it is among the most budget-friendly starter welders. The next thing that really impressed me was how well this unit started an arc. So, for example, when I did the Horseshoe pumpkin project, I made it a point to not cut the wire even once, so there was never a fresh tip, and even so, it had no problems starting an arc every single time. I cannot say that for my much more expensive Lincoln MiG Welder that is very touchy. I have to cut it every time, or if there's a little bit of ball left over or a little bit of heated up flux core, it won't start that arc and it starts feeding out and bending, and I have to go in and cut it. So I was really impressed with that. Next would be 3mm or 1/8" steel. I thought it performed really well with that, and as the penetration test showed, it was a good thorough weld. And the last thing I would say is it is really quiet. The fan only kicked on once when I was doing a ton of spot welds on this pumpkin project, and even when it did kick on, it was really quiet. A lot quieter than my Lincoln welder that has this kind of constant drone that goes on. Now let's move on to the cons. In my testing, this unit performed really poorly with that 1/16" box steel. I could not get a decent weld on any of the things I tried. So I actually reached out to Troozy with an email linked with pictures on the welds I was getting and asked for their suggestion on what I could do to get a better weld. And to their credit, they did reach out to me and responded. Here we go. So as you can see in this email, for 1/16 box steel, they recommended 8 to 10mm welding wire. They supplied us with the 8mm, so we've got that checked off. And they said quick welding is needed to prevent it from burning through, and they showed the setting that they recommended. And as you've clearly seen by watching this video, I had done all of those things they recommend and still got really poor results. Next would be excessive splatter. So every MIG welder I've ever used with the flux core has always had a certain degree of splatter, but I do think this unit produced a little bit more splatter than I'm accustomed to. Now I will say with that wire wheel attachment to my angle grinder, it cleaned off really well, but you are going to be spending more time cleaning up your welds than you are actually laying down the weld. So I would recommend perhaps trying a different brand of welding wire. I've watched videos where they run the same unit with several different types of welding wires, and you get much better results with some. I'll leave a link to it right up here. And I would also recommend investing in a can of that anti-splatter spray. Finally, I've beaten this to death, but the fact that it didn't come with a handle is definitely a con in my book. Now I'm going to do a follow-up video here in the next few months where I'm going to buy a different reel of wire. I'm going to have some of that spray, and I'm going to see if I can get some better results with that 1/16" box steel. Now, if you found this video helpful, will you please give it a thumbs up? It really helps the algorithms to start suggesting it to more viewers like you. Also, please consider subscribing. It is 100% free and it really helps out the channel. Now, I'm going to leave links to this unit and then all the other supplies that I used and talked about in this video. Full disclosure, those will be Amazon affiliate links. So if you click on them and end up making a purchase, it won't cost you a thing, but I do get a small reward at the end of the month. It helps to justify all the time it takes to set up these shots and do these review videos. And thank you to all of you that have been doing that. Until next time, thank you for watching.